This first question is testing you on your ability in understanding the momentum equations. They're usually given on all the quizzes, but I'm just going to rewrite them. So the change in momentum of an object is equal to the sum of forces that the object is experiencing over a given amount of time, which is delta t. Another equation you're going to frequently be using is the momentum of an object is equal to its mass times the velocity it's traveling at. So another way to write this is the change in an object's momentum is equal to its mass times the change in its velocity. So what you see here now, since these variables are the same, you can set this to this. I would like to first give you guys like an overview of what is physically happening. So basically you have the green is going to be the train, which is pushing Marty, which is who is in his car. So the train is exerting an amount of force onto Marty. However, Marty is also feeling the forces of gravity as well as a normal force, because the question states that they are on a frictionless track. A normal force that cancels out the force of gravity, meaning the only relevant force is really the one that the train is exerting on to Marty. So, let's shift this up here. Whenever I do a problem, I always like to extract the relevant information within it. So, the train, the only important part is that it's exerting a force of 20 newtons per second. That's all that's really useful. So now for Marty, we are given that the mass of the car is equal to 1,000 kilograms. The initial velocity is 0 because it says he is at rest, which is basically just another way of saying it's not moving at all. And the final velocity, the problem is basically saying that it's 40 meters per second because that's the speed it needs to reach in order to time travel. So with all this information, it's pretty much all you need to answer the problem. So the question is asking, how long does it take? And once you see the words, how long does it take, it should immediately tell you to use this equation right here because it has the variable delta t in it. So I'm just going to copy this over here. Alright, so like we discussed before, the only relevant information for the sum of forces is the 20 newtons. Oh, what in the world? Yeah, so that's the only relevant force because all the other forces, again, the normal force is being canceled out by the force of gravity. So those are basically zero values. Now, you only have a delta p that you need to look for, which you can obtain using the information given from Marty. So the delta p of Marty is equal to his mass, which is 1,000 kilograms, times his change in velocity. This is basically final minus initial, but since the initial is just 0, only thing that's relevant is the 40 meters per second. This will eventually give you 40,000 kilograms over meters squared. Alright, so again, like we discussed up here, since the delta p's are singled out, it means whatever they're equal to can also be set equal to each other. So now that we have a delta p, we know that this value is equal to the sum of forces, which is 20 newtons, multiplied by the change in time. So at this point, it's just doing basic math. You just divide both sides by 20 to isolate the delta t. So just to save you guys some time, it is 2,000 seconds. Another key point to know is that you should always, always, always write out the units of every value as you go through a problem. Sometimes on quizzes, instead of a meter, they will give you a kilometer or a centimeter instead. So you might have to do some unit conversions depending on the quiz you're taking. But if you write out your units throughout your work, it's always easy to see if you made any mistakes.